Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at arrays and functions. We're going to look at passing arrays to functions most of all, and we're also going to have a quick look at returning arrays from functions. So I'm in Eclipse as usual, and I've got my main function here, and I'm using the GNU compiler as usual. So I'm going to start by declaring an array here. Let's make it an array of strings, which I'll call texts, and put the array brackets in there, and I'll initialize that. So if we initialize it, we don't need to put the number of elements in the array as we've seen before. So let's initialize it with apple, orange, and banana. Now supposing we want to pass this array to a function, let's create a function up here. Let's make it void, I'll call it show. In fact, I'll call it show1 because I'm going to have probably 3 of these. Let's say show1. Now the kind of most intuitive way to pass an array to a function is to use the whole type of the array, which is string text and square brackets. So we don't have to call this text, of course. We could call it anything that we like. We could call it strings or whatever. We could call it anything, but I'll call it text just so I don't have to think of another name for this variable. And now we could pass that in. So we could say pass the array into the function. Let's say show1 and text like that. Let's loop through the array. So let's say for int I equals 0, I less than 3, because there's 3 elements in the array, I++, and we'll do cout text I endler. So this works exactly as you'd expect, pretty much. If we run this, we've got apple, orange, banana. Now there is a problem here, which is that when we pass an array like this, we lose the information about how many elements are actually in the array. To underline that, we could do cout here. This will work, cout size of text, and that's going to give us well, a string occupies on this with this compiler 24 bytes. So we've got 3 of them, so the whole array is going to be 72 bytes. So we get 72 there. But if we try the same thing here, for one thing, we'll probably, well, at least with my compiler, I'm going to get a compiler warning. So it's going to give me a warning, but it still builds, it's not an error. And so the warning is this stuff about size of on array function parameter will return size of string pointer. What we actually get when we run it is we just get the size of the pointer, which is the same as size of long, which is, at least with this compiler, which is 8 bytes. So we've lost the size information with this syntax. And for that reason, it's a common thing to do, is to pass in the number of elements in the array as a parameter. So let's say int elements, or we could call it n elements or something, to underline that it's, excuse me, to underline that it's an integer, it's a number. Let's say int element, n elements. And then we could pass that in here, so that's 3, and we could use n elements here, n elements, and because we definitely don't want to change this number, for good practice we should declare it const as well, so that we can't change it within this function. And if we run this, it works as before. I don't think we saw any compiler warnings there. Oh yeah, we would do because of this. So let's put a note here. Returns size of pointer. That doesn't work. And now if we build this, we shouldn't see, I don't expect to see any warnings here, so it's fine. Now another syntax that you can use, well, in fact this is exactly equivalent to doing this, where we pass a pointer like that. This is really exactly the same as this. There's not any difference. So if we do that, let's call this show2. It's going to work exactly the same. So these two are equivalent. And you'll recall that with a pointer, you don't have size information there. You have the information about how big the pointer variable is. It's 8 bytes because it contains a memory address that can take 8 bytes to specify, but we don't have the information about how many elements are in the array. You can even put a number here, like 3, but C++ will just completely ignore it. I could put 2 in there or whatever, and we can still merrily pass in an array with 3 elements. We don't even get a compiler warning with this compiler anyway. So this is really useless. There's no point putting a number there, except perhaps as just to remind you about the number of elements that are expected there. That's really the only thing that it's good for. If you do want to retain size information, you have to pass a pointer to the array. Let's show that. So let's call this show 3. Now we can get rid of the number of elements because we're not going to need it. And we can say string. So we'll say string text array just as before. And using this syntax, you have to specify the number of elements in the array correctly. So I'll say it's going to have 3 elements. Now to pass in a reference, you might expect that we'd just do this. This, if you recall the tutorial on references. But the problem is that this actually specifies an array of references to strings, which is no use. What we want is a reference to an array of strings. So we actually have to put round brackets around this bit, and perhaps this is the reason why this syntax, I haven't seen it really used much. It just doesn't look that nice, but it does work. And then we can use our old trick to get the number of elements in the array. We can say size of text divide by size of string, because we've got strings in the array. And if we do that, we can call show 3, and it has correctly, now it does have that information correctly about the number of elements in the array without putting apple, orange, banana here. So this is all working. And here, C++ will check that you're passing in an array with the correct number of elements. So if we change that to 2 and we build that, then we get an error. It won't let us run that. It's possible some other compiler might give you just a warning, but I'm guessing most of them will give you an actual error. You have to have the right number in there. That's kind of the point of it. So 3 different useful syntaxes there for passing arrays. I also just want to mention quickly returning an array from a function. So to do that, the thing to do is return a pointer. So we could say string pointer get array, let's call it. And what you must avoid is, let's create an array here. I'll put something different in it, like 1, 2, 3. Now you can return that text, but you mustn't. And in fact, if we build this, we'll get probably a warning, but not an error. So this has given me a warning, which is nice, but this is no good at all. Because what's happening is we've got this array which is scoped to these brackets. Then we are returning a pointer to that array, but that pointer will then point at something that no longer exists after this function returns. So you must not do that. Let's just put here don't return pointers to local variables, because that's really what this is. It's a local variable, and we can't return pointers to variables within functions because they don't exist anymore after you leave the function. If you wanted, you could in fact declare the array somewhere where it's available to all functions. So if I put this up here like this, let's call it something else, let's say numbers. And then here I'm going to return numbers. That would actually work. So if we build this, that would work just fine. It's a bit useless because why return something when it's available anywhere? But the point really of this is just to show you that you can declare variables outside of any function. and then they're going to be available in any function in your file below where you declare them. So whoops, let's say here could declare, if I can spell it right, variables here. Okay, but whatever you do, don't return a local variable from a function, because that's really going to mess things up. And if you do need to return an array from a function, you can just return it as a pointer, and that's useful. For example, if you've used the new operator within your function, let's take a quick look at that. Let's say we've got, I'll use char just for a change here, but this also applies to strings. We could say char pointer, I don't know, get memory, and in this function we could do something like char pointer p mem equals new char, and then some number of chars, let's say 100. We could return p mem. That's fine, because we're using new, we're explicitly allocating memory, and that will not be deallocated until you call delete on it. So now we could do char pointer p memory. I'll call it something different just to underscore that it is different. We could call it p mem again, it doesn't matter, equals get memory, like that. But then we have to remember to free that memory later. When you use new, the responsibility is entirely on you to free up that memory. So again, although this is quite common, clearly it's not ideal, because you have to know that this function, when you call it, you have to know that it allocates memory, because you've got to delete it. And again, quite a common thing to do would be to declare another function, let's say void free memory, which can take a char pointer p mem, and then all that's going to do is to call delete, like that, so p mem. And then here we could say free memory p memory. So this is also quite a common pattern in C++. Let's just run that and make sure it actually builds and seems to work. So if you create a function that allocates memory, it's common practice is also to create a function that deallocates that memory, and then in the documentation of your functions you can say, okay, if you call, in this case, get memory, you must remember to call free memory to deallocate that memory. So that's quite a common thing to do, just to avoid the user having to realize that they need to free an array of memory. You just provide them with a nice utility function to clean up whatever this function did and call them in pairs. That's a common pattern in C++. Okay, so to practice this, I'd recommend just trying all of these things. Try passing an array to a function using these three different syntaxes. Use an array, pass in the number of elements, use a pointer, and also use a reference to an array, and check that you can iterate through the array in your function. You might also want to try just doing this, creating a function that allocates memory and another function that deallocates some memory. And if you want, you can use that memory to do something, put some characters or strings in there whenever you're returning from that function. So try those for yourself, and try doing size of, like I've done, on the array variable that you pass to your function, so you can see how size of responds in these three different situations. And you can see if your compiler gives you a warning or not when you do something that you shouldn't do, basically. So that's it for this tutorial. It's definitely worth practicing that. Just try it for yourself, passing arrays to functions using these three different syntaxes. And until next time, happy coding.